Hi, I'm Guang, 15 years old. In this lesson, we'll have the techniques and applications of definite integration. So we'll take a look at what kind of new methods we could learn through this example here. Right, so this example is about a double integration for your Cartesian coordinates. And the range is bounded by x plus y is equal to 1, x is equal to 0, also known as the y-axis, y is equal to 0, or the x-axis. And your integrand is cosine x minus y over x plus y. Right, so let's draw out this boundary that we have. So this boundary, it should be rather simple for those of you who already know these functions. Alright, x plus y is equal to 1 is essentially y is equal to negative x plus 1. So plus 1 is the intersection with the y-axis, and since it's a negative x, it goes down. Alright, so this is x plus y is equal to 1. Now, x equals 0 is your y-axis. Y equals 0 is your x-axis. So you just have this area inside. Right, so this is our boundary. Now let's take a look at this example. Now, if you realize, no matter how you try to integrate this in its Cartesian form, it doesn't seem very possible, right? Since even if you just have a single integration, let's say cosine x minus 1 over x plus 1, you can't really integrate it, isn't it? Right, so this is where one of your special methods come in. What is the other coordinate system? The polar coordinates. Why am I talking about that here? Isn't this just a straight line? Don't we use polar coordinates just for those curves? Well, in this case, it is actually better to change it into polar coordinates. But why is that so? Now let's take a look at this. So x is r cosine theta, right? So x is r cosine theta. Y is r sine theta. These two add together is equal to 1. You can bring out the r for both, then divide whatever you have, which is cosine theta plus sine theta, to the other side. So in this case, you can actually find what r is in terms of theta. Alright? Now, so we can change this into double integration. Cosine r cosine theta minus r sine theta over r cosine theta plus r sine theta, and then r d theta. Right, our range for r would of course be from 0 to whatever we just had, which is 1 over sine theta plus cosine theta. How about our theta? Now theta, this is only in the first quadrant. So in the first quadrant, that will be from 0 to half pi. Alright, so this is the integration that we will have to solve. Now, if you realize, all inside here would actually all simplify. So that means we could bring out the terms of r to solve independently. And that is, you won't have this part, you just have r dr with this integration, which r dr you have half r square, and then substituting the values 0 to 1 over sine theta plus cosine theta. Okay, and cosine theta minus sine theta over cosine theta plus sine theta d theta. Right, so this is what you are going to see. We can bring the half out and then integrate from 0 to half pi. 1 over sine theta plus cosine theta squared. Cosine theta minus sine theta over cosine theta plus sine theta d theta. Now, at this step, you might be stuck here again. How do we proceed? So here we would use another, you could say another kind of method, or it's just something that you can try in general. Let's say we have another function, for example, ln something, and here you have 1 over something. What would you think of it? Of course, then you would have to test whether this something inside, when you differentiate, it becomes that. Why do you have to do that? Okay, how about let's just work it out first, and then you can decide for yourself later. Let's differentiate whatever's inside here. So d theta. Now, it's just within, we do not include the cosine. So we just have cosine theta minus sine theta over cosine theta plus sine theta. Now this, if you have learned differentiation, you would just straight away use your quotient rule. So quotient rule, you differentiate the numerator, you have negative sine theta minus cosine theta multiplied by your denominator, which is sine theta plus cosine theta, and then you subtract. So you have your numerator, and then you differentiate your denominator. And of course, this entire thing is divided by your denominator squared. Okay, so this is what you will have. Now if you realize both of these have a negative, how about let's take that out. So you have a negative. Now your first term is sine theta plus cosine theta squared. And your second term is plus cosine theta minus sine theta squared over sine theta plus cosine theta squared. Okay, so how about let's expand your entire numerator. When you expand your entire numerator, you'll have sine squared theta plus 2 sine theta cosine theta plus cosine squared theta plus cosine squared theta minus 2 cosine theta sine theta plus sine squared theta, and of course divided by your denominator. So how about let's take a look at what happens in the numerator. Now in the numerator, you'll probably realize this term here and this term here are the same, so they'll cancel out. Well, whatever's remaining is your sine square and cosine square. Well, you have these two parts that become 1 and these two parts that become 1. So it does have minus 2 over sine theta plus cosine theta squared. Does this term look familiar? If it doesn't look familiar, how about you remove a negative 2 and replace on top with 1? Well, of course, that's the term you have in front here. So this is basically what you can think of as a chain rule, but in reverse. So that means with an extra negative half, you would be able to bring this term into the d theta to become whatever's within your cosine. Alright? Okay. So you have a negative 1 over 4, integrate from 0 to half pi, cosine theta minus sine theta over cosine theta plus sine theta d. So I'll just remove this part. Cosine theta minus sine theta over cosine theta plus sine theta. Right, so this integration should be rather simple, right? Since cosine, you just have sine. So negative 1 over 4 sine cosine theta minus sine theta over cosine theta plus sine theta. And you have to substitute in the values 0 and half pi. Right, so when you substitute in half pi, you have 0 minus 1 over 0 plus 1, which will give you a sine negative 1. Sine negative 1 makes this negative, so you have 1 over 4 sine 1. Well, if you substitute in the other, so negative and another negative makes a positive, while your 0 becomes 1 minus 0 over 1 plus 0, which makes 1 over 4 sine 1, which creates half sine 1. Alright, so this is the answer you have in this example. So let's go through whatever methods we just had. Now, first things first, you will always determine what your boundary looks like so that you will be able to know how do you determine your boundaries for integration. Right, so then you have to determine it is a triangle, and with that triangle, you will try to find its boundary. But in this case, even if you find its boundary in Cartesian coordinates, it won't be really solvable. So the first special thing that you use here is to change it into polar coordinates, even though it is pretty, well, I guess you could say not that circular. And afterwards, did a little integration to change your terms of r. And the final thing that we use is actually to see whether you could have an application of, let's say, it's pretty similar to chain rule, since when you differentiate something, you differentiate outside first, and whatever special terms you have inside, you have to differentiate them again, which in this case, yes, you did have that kind of a case. So of course, when you're trying to integrate, these are some of the things you have to consider when you reach a roadblock, okay? So this is one of the ways that you could use to determine how you could integrate this function. And of course, after you realize this entire term in front could be put inside the d theta, you will just do your integration normally. And at last, arrive at an answer of half sine 1. Alright, so I hope in this lesson you'll understand everything. I'll be ending it here, and thank you for your watching.